Finding AI projects that truly help you learn and build real-world skills can be challenging. Many lists online are filled with recycled ideas that don't actually teach you much or solve real problems. The key to genuine growth in AI is working on projects that address practical needs and push you to experiment with new tools and workflows. In this video, we'll explore 5 hands-on AI projects, each designed to teach you valuable data science skills using Python and large language models. Whether you're a beginner or looking to level up, these projects are built to be useful, engaging, and directly applicable to real-world scenarios. Let's dive in and see how you can sharpen your AI skills with projects you'll actually want to try. Let's start with the first project, a Database-Agnostic SQL Assistant. In many businesses, non-technical users struggle to access data directly from databases. They often rely on data professionals to answer questions, which can disrupt workflows and slow down decision-making. This project aims to solve that by letting users query multiple databases in plain English, regardless of the underlying platform. By leveraging retrieval-augmented generation, LangChain, and LangGraph, the system translates natural language questions into SQL queries, executes them, and returns results all through a simple chat interface built with Streamlit. This empowers users to get the answers they need quickly and independently, making data more accessible across the organization. Here's how the Database-Agnostic SQL Assistant operates. A user types a question in natural language, such as, "Who were our top vendors last quarter?" The system uses a large language model to convert this question into a valid SQL query, which is then executed against the appropriate database. The results are returned in a user-friendly format. The architecture is designed to connect with various databases like Amazon Redshift, Google BigQuery, or local SQL instances, making it highly flexible. The Streamlit chat interface ensures that even users without technical backgrounds can interact with their data seamlessly. This project not only saves time for data professionals, but also empowers business users to make data-driven decisions. Building on the first project, the second idea enhances the SQL Assistant by adding intent detection and data visualization capabilities. While the original version returned plain text results, most users want insights in the form of tables and charts. This upgraded assistant not only translates natural language into SQL queries, but also generates Python code to create tables and visualizations. It detects user intent, whether they want to query data, visualize results, or adjust an existing chart, and responds accordingly. Using Chainlit for the front end, the assistant displays SQL, tables, and charts side by side, creating a clean and interactive user experience. This streamlines the entire process from data retrieval to visualization. With this enhanced assistant, the entire workflow from asking a question to seeing a chart is automated. Users can request quick reports, and the system not only pulls the data, but also visualizes it instantly. This reduces interruptions for analysts and helps business users become more self-sufficient. The assistant's ability to detect intent means it knows when to run a query, when to visualize results, and when to update existing charts. By integrating Python code generation and visualization tools, this project bridges the gap between raw data and actionable insights, making data analysis more efficient and accessible for everyone involved. The third project takes retrieval-augmented generation to the next level by applying it to unstructured documents. Searching through thousands of contracts or policy documents for a specific clause can be tedious and time-consuming. This project builds a scalable, modular, and secure RAG application on Google Cloud's serverless stack. It uses Python, LangChain, and LangGraph for logic, while Streamlit provides the user interface. The system connects to multiple Google Cloud services, including Cloud Storage, Cloud Functions, Cloud Run, BigQuery, and Vertex AI for vector search. This architecture allows organizations to add new data sources or models easily, ensuring scalability and security. This Scalable RAG system automatically extracts text from PDFs, computes embeddings, and stores them in Vertex AI vector search. When a user asks a question, the system retrieves relevant document sections and provides answers through a chat interface. The modular design means you can add new retrievers or models without disrupting the entire pipeline. Security and scalability are built in, making this project suitable for enterprise environments handling millions of documents. By automating document search and Q&A, this project saves time, reduces manual effort, and ensures that critical information is always accessible when needed. The fourth project addresses a common challenge for anyone working in AI: information overload. With new research papers and techniques emerging daily, it's nearly impossible to keep up manually. This AI research assistant connects to the arXiv API, retrieves the latest papers, and summarizes them using the IMRAD format: introduction, methods, results, and discussion. It uses prompt caching to avoid redundant LLM calls, saving time and reducing costs. The interface, built with NiceGUI, offers a scrollable feed of research summaries, including both scientific and simplified explanations. This tool helps you stay up to date with the latest developments in AI without getting overwhelmed. The AI Research Assistant is designed for efficiency and flexibility. By summarizing papers in a structured format and providing both technical and layman explanations, it caters to a wide audience. The use of prompt caching ensures that once a summary is generated, it's stored locally, minimizing repeated API calls and keeping costs low. The NiceGUI interface makes it easy to browse through research feeds, access direct links to papers, and quickly grasp the key points of each publication. This project is not limited to AI research. It can be adapted to any field where staying current with literature is essential. The fifth project introduces a multi-agent system that automates web scraping and dashboard maintenance. Maintaining data pipelines and dashboards can consume a significant portion of a developer's time, especially when web structures change or visualizations need updates. This project uses autonomous agent systems that can reason, plan, and act independently to manage the maintenance loop. The system powers a self-sustaining sentiment analysis dashboard with specialized agents for data scraping, visualization, and refinement. Everything is coordinated through LangGraph's React agents, and the data agent uses Crawl4 AI for robust web scraping. The result is a dashboard that stays up to date with minimal manual intervention. This multi-agent system is composed of three main agents: the data agent, which scrapes news outlets and performs sentiment analysis; the visualization agent, which creates dynamic charts and diagrams; and the refinement agent, which reviews and improves the dashboard. By delegating tasks to specialized agents, the system can adapt to changes, repair issues, and ensure the dashboard remains functional. The use of Crawl4 AI makes the scraping process resilient to website changes, while Streamlit provides a user-friendly interface for viewing results. This approach reduces maintenance time and allows teams to focus on building new features rather than fixing old ones. The sentiment analysis dashboard generated by this system is both informative and visually appealing. It features Sankey diagrams, bar charts, and word clouds to present data in an easily digestible format. The visualization agent ensures that the charts are always up to date, while the refinement agent continuously monitors and improves the dashboard's performance. This self-sustaining system demonstrates the power of combining autonomous agents with modern visualization tools, making it a valuable asset for organizations that rely on timely and accurate data insights. One of the most exciting aspects of these projects is their flexibility. You're not limited to following each one exactly as described. For example, you could build a scalable RAG system for SQL, hosted on Google Cloud, or combine autonomous agents with a document pipeline to create self-improving data systems. The skills you develop from these projects, natural language processing, data visualization, cloud architecture, research automation, and agent-based systems, can be mixed and matched to tackle new challenges. This encourages creativity and helps you build solutions tailored to your unique needs. By working through these 5 projects, you'll gain hands-on experience in several critical areas: transforming natural language into SQL queries, automating data visualization, building scalable cloud architectures, summarizing research with AI, and orchestrating autonomous agents. Each project is designed to teach you a different aspect of modern data science and AI development. These skills are in high demand and will help you stand out in the field, whether you're looking to advance your career or build innovative solutions for your organization. These 5 AI projects are more than just exercises. They're opportunities to build something useful and impactful. Whether you're interested in making data more accessible, automating research, or creating self-sustaining dashboards, these projects provide a solid foundation. Don't be afraid to experiment, combine ideas, and adapt them to your own needs. The world of AI is evolving rapidly, and hands-on experience is the best way to keep up. Start building, keep learning, and you'll be amazed at what you can achieve with Python, LLMs, and a bit of creativity.